Alright, welcome to Jaka Quantics. In this tutorial, I'll be putting us through how to measure a pavement, rigid pavement measurement. In the previous class, we talked about flexible pavement, that is pavements, the roads with asphalt finish, right? Asphalt roads, they are called flexible pavements. Now we'll be looking at rigid pavement. Rigid pavements are pavements with concrete roads. Basically concrete roads, right? Pavement with concrete, right? That's what we call rigid pavement. And we'll be using the same reference like in the previous video for flexible pavement, which is what you can see here. This is question from it TPC exam for the NIQS, and they are basically almost the same thing, just slight differences. Now let me explain from here. Now you can see here we have the subgrade, we have the sub base, we have the base course. It is the same thing for the rigid pavement. The only the differences are in the rigid pavement, you don't have the binder course, you don't have the surface course, you don't have the prime coat, you don't have the seal coat, you don't have the tack coat. All right, but you have the same subgrade, the sub base, the base course, and then the concrete itself, the concrete road itself. So we'll be using this so that we don't have to repeat what we have already repeated in the flexible pavement measurement. All right, I hope we get it. So we'll be using this also. All right, now let's come here quickly. Now this is what we have. All right, and of course every measurement you have to prepare your taking off list. You have to prepare your takeoff list. See, I put in here the reference standard method of measurement I use, which is the BSMM 4R, and of course all their references are there. You can check them up. It will actually make your own work easier. You can easily trace them from the BSMM 4R and then apply them to what you want to do. All right, okay, now this is what we have. This is our takeoff list. We have general items. We have of course the excavation to level, compaction, the subgrade, the sub base, the base course, the road marking, and then the road median. This is the concrete. Let me add a few. The concrete, we have concrete. Let me say reinforcement also. Reinforcement. All right, then the road marking, and then the road median. Also not forgetting to include the channels. All right, channels that is used for form work for the rigid pavement. All right, now these are the general items. Now we've already talked about this in our previous video. Okay, and these are the references in the building engineering standard of measurement 4 revised. So we'll not be going through them again. Now we know the road is 2.2 kilometer road. It's a 2,200 meter road. All right, so excuse me. All right, now the demolition and site clearance, we have to do a complete takeoff. All right, so we have to clear the site. We have to of course assume that we are going to clear the site and demolish whatever it is not there. This also we have done in our previous video, clearing of site vegetation. And then the earthworks, of course there might be some cutting and some fillings. There might be some cutting and some fillings. Right, so this is what we have here in the earthwork. Earthwork is in section 2E of the BSMM 4. That is the civil engineering measurement aspect of it, right, towards the back end of the BSMM 4, towards the back, not back end, or towards the end of the BSMM 4R. From the beginning is they are for building works, then towards the end they are for civil engineering works. All right, so maybe topsoil, maybe cutting, and maybe some filling. Right, so this is their respective references. This we have treated also in our previous video on flexible pavement, so I don't want to go back there so that the video does not become unnecessary too long. So the road and pavements. Now, this is basically what we have here. Of course, they are in the same section. Rigid pavement and flexible pavement are in the same section of the BSMM4R. Right, 2T, 2T. Flexible pavement, 2T. Rigid pavement, section 2T. Alright, so it becomes easy to make reference to. Of course, this is a subgrade. Like I said, we have the sub base, we have the base course. It is the same thing. The same thing. The only difference is that, as you can see, you don't have the binder course no more. You don't have the surface course no more, and the prime code, the tack code, the seal codes, you don't have them no more, because we are dealing with a rigid pavement. So we go straight to the concrete pavement itself. Everything here as per what we have done in our previous video on flexible pavement. All right, the concrete pavement, so we'll just treat it straight away. All right, so this, we know the road width to be 21,100, right, and the median is 300. This is what we have here, right? This is what we have. This is the road width, this is the median. Okay, all right. Effective width, by the time we remove the median, is 2,800. If I divide by 2, it is 10,400. And of course, the entry is as follows, right? So you see, this is 2,200 and the width is 10.4, like we rightly measured. The length is 2,200, that is 2,200 meters. I already did that explanation in the previous video. You can see here in the previous video, and I said also your waist calculation is in millimeters, especially if you're writing an exam, but if not, you don't need it. It's in millimeters, while your entry should be in meters. This is the total length, 2,200. Where is that? Okay, now the width is 10.4. I have it for two sides of the road. That's why you see it is multiplied by 2. It is in square meters. Did I put it here? It is in square. It is measured in square meters. If you check your BSMM4R section 2T, it is measured in square meters. See the description here: concrete pavement, joint, third reinforced concrete surface slab, maximum thickness not exceeding this. You can check it out in your BESMM4R. Now, after the concrete, the next item will be our reinforcement. All right. Our reinforcement. Okay, now I was able to create a mat here so that you understand what the reinforcement looks like. I said, okay, I think I wrote it here. Now the total length is 2,200,000, right? That's in millimeters. That is in millimeters. So that if I divide, it becomes 2,200 meters. Right, so if I want to know how many panels are there, I say, okay, let's assume they are casted in panels, because when you're casting, you don't cast everything once. You cast in panels, and you create room for expansion joint, because concrete also expand when heated and contrast when it is cool. All right, so for us to know how many panels we are going to say, let's assume there are 18-meter panels. Let's say we cast the road in every 18 meters. It could be every 10 meters. It could be every 9 meters. It could be every 20 meters. Right? Now, let's say we're having it in every 18-meter panels. How many panels are we going to have? Right? So this is basically this divided by 18,000 is in millimeter. Right? So we're having 1,224. 1,224 number of panels is what we are going to have. So it means this here will have 1, 2, another one, another one, another one, to cover for that length of road. 1,224 panels is what we are going to be having. All right, so these are the vertical members. Now these are the horizontal members. Of course, we need to calculate, the reinforcement. So I already did a waist calculation here. All right, so this is basically what we have. Now these are the vertical members, these are the horizontal members. These vertical members, of course, we said they are 18 meters, while the horizontal members defines the width of the road, which is 10.4. Remember, the road is divided into 2 now, because you have a median in between. All right, so if I have if I pick, let's say I want to calculate the vertical members, which are 18 meters, right? How many number vertical members am I going to have? Right, now you see the vertical members, right? See what I have here. These are the vertical members. Now these are the horizontal members. Right, for me to know how many number of vertical members, I'll have to of course, you see they are running. See, this is vertical. Now see the vertical here running across the horizontal members. So for me to know how many number of vertical members I am going to have, we divide by the width, because the width that will determine how many vertical members. Now you see what I have here. This is 10.4, right? We determine how many number of these I am going to have. So this is 10.4 divided by a spacing. Okay, spacing 200 mm divided by a spacing of 200 mm. Of course, you plus 1 because you are dividing by spacing. Where you're starting from, you are going to put 1 reinforcement there. This is what we have. This is 10,400 divided by 200 plus 1. That gives us the number of reinforcement we are going to have there. So this is 53 numbers. It gives us, we are going to have this number here, 53 numbers of them. The same thing if I want to do the horizontal members, which is this. You see these members, they are running towards the vertical members. Why this one? The vertical members are running towards the horizontal member. That is why you see. Now if I want to do for the vertical members, the horizontal members, I have to divide with the vertical members to know how many number horizontal members I'm going to have. Now this is the horizontal member, 18 meter. So 18 meter divided by the 200 at 0.2 plus 1, which is what I have here. 18 divided by 0.2 plus 1, and this will not be right. This is 18,000 because this is waist calculation, divided by 200. It has to be in millimeters. All right, I'll still have the same thing. This is what I have, 91 members. So the vertical members, they are 53, while the horizontal members, they are 91. And of course, the unit is in tones. The unit is in tones. So you see how I presented them here. 18. Now this is just for exam sake. If you're not writing an exam, you don't need all this paparazzi, right? If you're not writing an exam, you don't need all this paparazzi. Now I'm showing you, except you have a colleague that will vet what you have done. Even at that, you don't even need all this paparazzi, right? He knows what you answer. He knows how to check and how to say if you're right. But it is always good though, if you're presenting to someone else, somebody has to know how you arrive at your answer, and that is the essence of the exams. All right, so for the horizontal, what did I put here? Okay, this is for the vertical members, we have the length is 18. All right, so how many numbers are there is what we just calculated, which is 53 numbers. Now how many panels? We have 1, 2, 3, 4 panels. Now we have it for two sides, right? One side and then the other side of the median. The same thing for the vertical members. So this is for the horizontal member. This is 10.4, right? Which is this horizontal member, 10.4. How many are they? We have 91 of them. How many panels do we have? 1, 2, 2, 4. Now we have two sides of the divide because you have a median. This is what we have here. 91 number times the number of panels times 2 for the two sides of the row divided by the median. So this is how you arrive at your figure. Yeah, see already, this is already in tone. See, I already divided by 1000. I already divided by, so it's already in tone, right? So I'm doing this because back in the question says you should prepare a detailed bill of quantity. Now I've described the difference between a detailed bill of quantity and a draft bill of quantity. A detailed, you have to put units, you have to put quantity, you have to put rate, you have to put amount. But in a draft bill, you only put units. You don't put quantity, you don't put rate, you don't extend to have an amount. Now remember we said that we're done with the reinforcement for that. Now we have dowel bars. Now remember we said the concrete are being cast in panels. Now from between one panel and another panel, there must be a connection. So we call them dowel bars. That is, this is one panel. If I'm having another panel here, there's something should connect between this and this. And the space you fill with expansion joints, filler or something. Now this is what we have. So the dowel bar connects this to this. Most of the time it is 600 mm. It can be more depending on what they are trying to achieve. So 600 mm, 300 mm, we enter this panel, sorry, and the next 300 mm will enter the next panel, so it forms a connection. 300 mm coming from here, 300 mm coming from here, and you cast them to create that bond, and then you fill the in between with maybe a joint filler. That's an expansion, because this is an expansion. An expansion joint is created at that point. Okay, this is the dual bar, right? So how many dual bars are we going to get? Multiply by the number of panels, and then multiply by the two sides of the road. Now this is what we have here, the width of the road, because the dual bar is coming along the width of the road. All right, so how many are we going to have? Let's say that, okay, see it here, 300 mm spacing. It is not in a question. I am just putting that because it has to be at a particular spacing. All right, now if they are 300 mm spacing, it can be 200 mm, it can be 250 spacing. All right, so this is just an assumption. So if you're working on a real project, the spacing will be there. You will see the spacing. You'll be given the spacing for the dual bars. So 10.4, which is the width of the road, divided by the spacing plus 1, because where you're starting from, you are going to put one reinforcement there. So we have 36 numbers. That's what I have here. So we have 36 numbers. All right, now you see the dual bar here. This is the entry in the dimension column. This is 0.6. Now how many numbers do I have? I have 36 numbers. The number of panels times 2 for the two sides of the road, and of course here I already divide by 1000 to give me this in tons. All right, that is what I did here. What I did here is what I did: 36 times 1224 times 2. Now I multiply by this to convert to kg, then divided by 1000. All right. Okay. All right. Now, excuse me, I observe something here. Here, for me to convert this item to ton, I think it has to come here. It has to come here too. For me to convert this item to ton directly from here, then I think I need to multiply by. I need to convert to kg first. All right. This here. No, let me put it inside, times 0.888, that is 12 mm. All right, then before I divide by 1000, this is now in tons. It has to apply here too. What reinforcement did we use here? 8 mm, that is. So this is supposed to be like this, times 0.888. all right, before I can divide by 1000, because I have to take it down to kg, then divide it by 1000. Now I already explained how you get the value in kg. This is not all right, times 0.888. let's discover that now, divided by 1000. Now you have it in tons. Now it is now in tons. All right, so because you have to multiply by the weight of the reinforcement in kg per meter, then you convert to tons. All right, so this is correct now. Okay, then okay, having done with the dual bars, the next item is waterproofing. All right, with dual bars, you can see it is at section 2T.5.7.5. Please refer to the BSMM 4R 2T.7.5.7.5. Now you have waterproofing. Now of course, you waterproof to prevent upward movement of water and to prevent destruction of what you have executed. So concrete pavement separation and waterproofing membranes, section 2T.5.10.0. you can refer. So of course it goes through the length of the road by the width of the road, 2200 meters times 10.4 meters times 2, because we have two sides of the road. It is in square meters. Now we have expansion joints also. We have expansion joints also in 2T.6.3.7. Of course, remember we said the roads are in panels, and when you have roads in panels, between two you have a narrow spacing between where you use donut. Remember we said we use dual bars to connect, so you have to fill with expansion joint filler or to whatever is specified in that particular project. So joints in concrete pavement, expansion joint, this is because the depth of the road is 300 mm, so 250 to 300 mm. You feel it is in linear meters, right? 1224 is number of panels we have times 2, because we have two sides of the road, and of course it is 10.4 width. Okay, of course in building SME, in building building works, you see we have form works for concrete, form work to beam, form work to basement, form work to concrete bases or column bases. Here we're using channels, right? Channels, it gives you straighter edges compared to form work, and it's difficult for it to, is it sag, is the word sag, to, how will I put it, prevents honeycombs, one, and it does not bulge. Is it bulge or bulge? Bulge. It does not bulge with pressure. All right, so channels are used. All right, so we have in situ concrete channels, of course, as form work. This is maximum thickness 300 mm width. You can see it also in the BSMM 4R. They are measured in meters. All right, we have 1224 panels. Now you have the channels on one side and on the other side. All right, the same thing on the other side of the road, because you have to put it on both sides of the road. Now you can see here 1224 times 2 times 2 again to cover for both sides of the road divided by the median. See what I'm saying here? All right, this is the road, this is the median. So we have one side, we have the other side. So the concrete ancillaries, this remains the same thing. All right, now ancillaries, we have road markings. The same way you put markings on flexible pavement, you put markings also on rigid pavements. Right, 2T.8.2.5. right, it goes the whole length, 2200 meters. We have it for two sides. Now we have the median. We have the median is in section 2H, that is a precast concrete. The median is a precast concrete. Now we've done this before in flexible pavement. We have 880 numbers. We have the length is 2500, total length is 2,200,000 millimeters. So if I divide, I have this, what I did here. Right, we have the actual, we're not dividing by the spacing. That's why I said I didn't add +1. We're not dividing by the spacing, we're dividing by the actual length. All right, so that's why you have 880 number, section 2H.1.6.1. Now if you in the flexible pavement, now I used precast concrete for building works here, right, and I also use the earthworks for building works also here, but I changed them. I made a comment in that particular video, but everything is corrected here. 2E is earthworks in the civil engineering measurement, but in building measurement it is 1.5, section 1.5, but here it is section 2E. All right, so this is basically how you carry out the measurement of a rigid pavement. The difference is just the concrete reinforcement, formwork, and channels. Yes, concrete reinforcement and channels, that is just the difference. All right, because every other thing remains the same. You have the subgrade, you have the sub base, you have the base course, but you don't have the binder course, you don't have the surface course. So this is the bill of quantities, the BOQ. Of course, remember it is not real, right? So if it's an exam, you're not expected to put real rates. Just assume reasonably. These are the general items, these are the demolition items. Now you see, we're not giving any detail for excavation or for cutting and filling, so we allow them as sums. All right, then the road pavings, and now the reinforced concrete road. Now this is total unit quantity of the road. This is not in units, cubic meter, sir. It is in square meter. BSD civil engineering measurement says it's in square meter. Let me copy this and paste here. All right, but in building works it could be in square meter or cubic meter. When it's not, if it is 300 mm. All right. Excuse me. Okay, and the reinforcement also, we have it in tons, door bars in tons. Then the waterproofing, we already work on that in the flexible pavement, the expansion joints also. We have expansion joints now. Is in expansion joint is not in square meters, is in meters, sir. Expansion joint is in meters. Alright. Then we have the ancillaries, which is the road markings. Road markings in square meter. Is that possible? No, sir. Road marking is a linear item. Is a linear item, yes. It cannot be in square meter. Then we have the precast concrete, which is a number item. Alright, so this is how you prepare. This is a detailed bill of quantity, because now you see you have quantity, you have unit, you have rate, you have amount. If it were a draft, you are going to see only unit. As a matter of fact, this will not be squared. These items will not be squared. Okay, now I also explained something in the BS in the first tutorial on flexible pavement. This color here, I put them as brackets. You know, if you're measuring with pen and paper, you bracket. You don't want measurements, you bracket it. I am done with this measurement. You go to the next one. When you're done, you bracket it. That is what this stands for, bracket. All right, so it is not just for fancy. I am bracketing what I have done so that I can go. I'm done with one item of measurement. I'm going to the next. That is what bracketing, excuse me, does. All right, so this is how you measure a rigid pavement. Now you see, it's quite similar to what you have in a flexible, but the flexible does not have concrete, does not have reinforcement, does not have channels. All right, but you have them in the rigid pavement. I hope this video helps you in your academics, helps you in your professional career, and helps you in your next project. This is Chaka Quantics. I'll see you in the next video. Thank you. And I already said thank you. Okay, now this is part 2. Part 3 will be coming out, and part 3 will be for earth balancing. Part 3 will be earth balancing. All right, cutting and filling and the likes. Thank you. I'll see you in the next video. How many thank you have I said now? Like 2 or 3. All right, don't worry, guys. I'll see you in the next video. Another thank you.